Welcome back to Geometry. We're at section 10.5, Trigonometry and Area. Before we start, let's remember that only time we can use trigonometry, excuse me, let me change the color, there we go. The only time that we can use trig on a triangle is if it's a right triangle. So as this triangle sits, we can't use trig yet because there's no 90-degree angles in this triangle. Okay, but as you see, we're going to change that. So label the following triangle ABC. So we're going to label A is going to go up here, B is going to go up on top, C is going to go down in the corner. They also want us to label the corresponding sides A, B, and C. So here's what they mean. The side opposite angle A is going to be lowercase a, that's this whole length. The side opposite angle B is going to be lowercase b, which appears to be our longest side on this triangle, and then the side opposite angle C will be lowercase c. Okay. Next, they want us to draw in an altitude from B to AC and label it H. So here comes our height, our altitude. Remember, it's going to come down and it's going to create a 90-degree angle down here and here. We're going to call this H. Alright, next. Is there a way that you can find the length of the altitude if you knew the measure of angle A and the length of C? Well, yes, we can do that. We could take sine of angle A, which would equal the opposite side H over hypotenuse. And so again, I'm focusing on this left small right triangle, and I can use trig here because we have this 90-degree angle. So sine of angle A would equal H over C. Next, if I put a 1 underneath sine of angle A and I wanted to solve for H, okay, now I have sine of angle A over 1 equals H over C. Well, let's cross multiply. 1 times H is H. Sine of angle A times C is going to be sine of angle A multiplied by C. So what we're doing right now is we're actually leading you to the new formula for the area of a triangle using trig. And instead of just giving you that formula, we're trying to show you why it actually works. So that's why we're doing all of this work. So we found out our height. Okay, our height in this problem is going to be sine of angle A multiplied by C. And if I think of the formula for the area of a triangle, I know that it's 1/2 base times height. Okay, so I'm going to take 1/2 multiplied by the base, except this time the height is not going to be the height. We just found the height to be sine of angle A multiplied by C. Now, just like if I took 1 times 2 times 3 times 4, we know that's going to be 24. Since I'm multiplying all of these together, I can reorder them any way I want. Like I can do 4 times 1 times 3 times 2, that's still going to be 24. So I'm going to rewrite this as 1/2 B, and I'm going to move the C in front, and then in parentheses I'm just going to have sine of angle A. And this becomes our formula using trig to find the area of a triangle. Area is equal to 1/2 BC sine of angle A. Alright, let's add in our notes that sine of angle A, this is always going to be your included angle. Okay, and I'll show you what that means later in this problem down here. So it's an included angle. And then I think it'd be good in your notes to know that B and C, you know, this is our side of a triangle, and same with C. Okay, so both B and C, they're just sides of our triangles. And again, hopefully this will make sense as we go. Alright, so here's our first problem. And generally speaking, again, in order to use trig, we need a right triangle. And I don't see one here. Okay, but remember, this formula is assuming that you're going to draw down your own height. Welcome back to geometry. We're at section 10.4 perimeters. All right, sorry, I'm back. Anyways, it is implied that you would draw down your own height, or this formula will do it for you. Okay, and so here's our 90-degree angle. So even though we're going to use trig and you don't see a 90-degree angle here, remember that it's implied that you're going to draw in your own height just like we did up on top. Okay, so the other thing that I like to do is I like to highlight my B and C. So 4.3 is my B, and then my C is going to be 6.5. So, and again, B and C are interchangeable. You could have C be 4.3 and B be 6.5, or vice versa. And 39 degrees is my included angle. Here's my included angle. Okay, so I'm just going to plug everything in. Area is equal to 1/2. B is going to be 4.3. C is going to be 6.5. And then sine of 39 degrees. And once you multiply all this out, I believe you're going to get 8.8 units squared. Alright, next problem, again, I'm going to highlight my two sides. Here's B and C, so I'll let B be 152, C can be 192. We have our included angle, and I just plug this into our new trig formula. Area is equal to 1/2 152 times 192, and then sine 73 degrees. Alright, and then that would be a huge number for your answer. Alright, then last problem, we have two sides of a triangular plot are 120 and 85 feet long. So let's draw that out. We have 120. We have 85. And then let's close that triangle. We're also told that we have a 85-degree angle. So we're going to highlight our two sides. Let's let this be B, and we can let 85 be C. And then our included angle is going to be 85 degrees. And so we're going to write area is equal to 1/2 120 times 85 times 85, or sine, excuse me, times sine of 85 degrees. And when we multiply all that out, we get 5,080.6 feet squared. Alright, let's keep moving down below. We know the formula for the area of any regular polygon is area is equal to 1/2 apothem multiplied by perimeter. And so before we've relied on 30, 60, 90s, and 45, 45, 90s. Well, this time we're going to find out that we can't use 30, 60, 90s and 45, 45, 90s, and here's why. Here comes our center point. We're told that the regular pentagon has side length of 14, so these go all the way around, 14 all the way around. We're going to draw down our apothem. We don't know that length yet. We're going to draw in a radius. We don't know that length either, but we do know this is going to be 7 and 7. And so in the past, we've used our knowledge of 30, 60, 90s, and 45, 45, 90s. Well, we have to think about these angle measures. There are 5 sides in a pentagon. There's 180 degrees total. We get 540 degrees. We divide that by 5, and we get 108 degrees for each angle. So all these angles are 108, which means this angle right here is a 54-degree angle because it gets cut in half by the radius. This is our radius. This is our apothem. And that means this angle up on top would be 36 degrees. So I'm going to redraw that triangle out. I have a 36 degrees up top. I have a 54 degrees in the corner. What else do I know? I know that this length is going to be 7. I'm trying to find A. I'm also trying to find R. And actually, I don't care about R. I'm only trying to find A because once I find the apothem, I can then find the area of our shape. And remember, area is equal to 1/2 lowercase a multiplied by perimeter, which is going to be 14 times 5, which is 70. So we know that our perimeter is 70. So as soon as I find A, I can find the area. All right, we're going to use trig. We're going to take tangent of 54 degrees is going to equal A over 7. And if I enter in tangent 54, we get 1.4 equals A over 7. And multiply that by 7, and we get 9.6 is going to be equal to our apothem. So 9.6 multiplied by 70, and that would give us an answer of 337.2 centimeters squared. All right, next we have a regular octagon with a perimeter of 80, so all these side lengths are 10. We're going to draw down our apothem. We're going to draw down a radius. Here's A, here's R. And just like before, I'm going to redraw this triangle so that it's bigger and I have more room to work with. Here's A and here's R. Alright, what do we know? An octagon has 8 sides. 8 minus 2 times 180 degrees would give me 1,080 degrees. And we divide that by 8. And 1,080 divided by 8 is going to be 135 degrees. We have 135s all the way around. If we take half, so again, this whole angle is 135. If we divide that by 2, we get 67.5 degrees. So this angle is a 67.5 degree angle. We also know that if the side lengths are 10, then this is going to be 5 and 5. Our base is 5. And so we know that this angle down or up here is going to be 22.5 degrees. And again, let's use tangent 67.5 is going to equal A over 5. And so tangent 67.5 is going to be 2.4. 2.4 equals A over 5. And we can round up. A is going to be 12. That's our apothem. So let's enter that into our formula. Area is going to equal 1/2 12 times 80. And 6 times 80 would be 480. And I guess let's go units squared. Thanks for joining us. See you next time.